All right, looks like everybody's pretty much here, so let's get started for today. So lecture 11, so this is the second to last lecture. So we're gonna do a two-part lecture on web application frameworks, which is kind of the most modern way to make your web apps. And specifically, we're gonna cover one specific framework, which some of you might have heard of, which is called Node.js. And that's commonly used with this package called Express. So when you hear about people making web apps with Node.js, they often use this thing called Express with it. So it's called Node.js and Express. So this is one of many web frameworks you could use potentially to make your projects. And learning objective today, it sounds a bit long, but this is actually pretty comprehensive. This is for today and tomorrow as well, which is to create a super simple version of Facebook, yet again, this time using a modern web application framework rather than the 1990s style CGI scripts that you've seen in the beginning part of the class. And this is important because this is a self-contained kind of simple example that actually illustrates this modern CRUD plus AJAX web app concept with a REST API, which is what you just learned 2 lectures ago. And this is of the sort of project you might build for your final project, right? So remember, for your final project, you have to build a CRUD plus AJAX web app. That's the requirement, the minimum requirement for your final project. You don't have to use a REST API, but it might simplify your code and make it more kind of conformant to standards if you do, but at least you have to do a CRUD plus AJAX web app. So by today and tomorrow's lecture, we'll kind of build up a good self-contained code example of that you can feel free to adapt into your projects if you want to do Node.js. But of course, you're not bound by using this specific technology. If you're familiar with other sorts of web application frameworks or other technologies, you feel free to use that as well. But we had to have something to teach in these last 2 lectures. I just picked one. Recall last time we did this Web 3.0 style bi-directional communication with the socket. Remember this the socket.io library that we use, socket.io library we use for bi-directional communication. So this was the idea that instead of having the browser or client always make a request and the server makes a response, with the bi-directional communication, the server can just send stuff to the client and vice versa without anybody making any requests. So it's much more interactive, like a instant messaging app or a multiplayer game where you're all just sending messages and state to each other without having to make separate requests and responses. And if you recall from that lecture, we started using Node.js in that lecture and introducing it. So that might have been a little confusing because we didn't really officially go over what Node.js was, but I promise you that in this lecture, we will go over it again. So if some of the code in that previous lecture with the socket.io was a little confusing, don't worry about it because we're going to basically do the same framework again. So full schedule today. As usual, we're going to spend the first half or so going through concepts and the second half going through the code. So it's a pretty big agenda. So the first part of today, what I want to do is kind of do a flashback, right? So how did we used to build web apps without using these modern frameworks? So far in the class, what have been, I guess the first Web 1 or 2.0 part, like what have we been using on the server side? Hear various mumblings, yeah. Yeah, so we use this technology called CGI, which is very old. So CGI stands for Common Gateway Interface, was one of the first, pretty much the first technology when the web started to allow people to run scripts on the server. And this dates back to the 90s. So this is pretty old. I mean, some people still use it today, but it's pretty bare, kind of minimum, a bare minimum. So recall that with CGI, this was all of our code so far in the first half of the class use CGI. I'm just going to the GitHub repository. Let's just choose. So remember in CGI, you have to put all your files usually in some CGI bin directory. So that, whoa, what's going on? Update. Did not want that. You have to put all your files in some special CGI bin directory and set up your web server, usually Apache, to say that this directory, everything in here is a script, is a CGI script or program that you should execute on the server, and then it should print some results. So let's do lecture 3, so it's the simplest one. So recall that this is in Python, but CGI scripts, again, can be written in any language, so we just chose Python. So usually languages that support CGI have some library that handles CGI, so you import CGI, and then you grab the data from the form that the user has sent you. And then the way that CGI works, as you've seen in the previous lectures, is you simply print out the HTTP response just in plain text. So this example you first print the header, which tells you content type, whatever. Remember the empty line, and then you print the body, which is just, in this case, a straight up HTML file with some CSS. So this is pretty simple and reliable and works, pretty well so far. So again, the diagram here for CGI scripts is, so I'll just give you the Python example here. So the diagram, as you've all seen many, many times, is the following, right? You have a browser or a client. You have a server on here. On this server, there's a server software usually called Apache. And then Apache has some kind of CGI functionality on it, I'll say. Like Apache supports CGI. So then what happens is when you make a request, let's say you make a request for this file, what is this called? lecture3.py? lecture3.py. When you make a request, this is through HTTP, everything is through HTTP. The server now finds lecture3.py on the server, then runs it using Python, because it's a Python script. So it runs Python. It runs this program, right? Apache handles this request, launches a Python interpreter, runs this, and whatever it prints out, anything that it prints out, all those print statements, pen just died, all those print statements go to the, all these prints go straight back to the client's browser, and it fills up the browser with data. Right? So in CGI, all you're doing is literally, like in the literal sense of the word, you're literally printing stuff. And whatever you print just gets streamed back to the browser, and this is an HTML file or CSS or whatever you want. And because this is a script on the server, you can say access a database on here, you can communicate with the database, you can communicate with files, you can do whatever you want and just send a bunch of data back to the client or the browser. Does that make sense? So this is what you've been doing all along. And this is a perfectly fine way to build web apps. I mean, for many years, web apps have been built like this because it does all the stuff you need, right? You need to make a request, does some calculation on the server, you can maybe access a database, access some files, then print out the responses to the client. So in Web 2.0 fashion, what you can do is instead of printing the whole web page, you just print some JSON data, and then the JavaScript on the client takes care of it. But essentially, all you're doing is you're launching some program written in a language like Python or Perl or Ruby or whatever, and then printing stuff out. So that's CGI in a nutshell. So this has endured for many, many years, and will probably still endure because this is what by default comes with Apache, the web server. And so if you get a hosting service, most likely your hosting service will run these simple CGI scripts. Okay, so time to brainstorm. So what are some of the limitations of CGI as we've introduced so far? So the first thing I want to say is it does what you need, right? You can't, if you want to build your whole project using CGI, that's perfectly fine. We have a lot of example code from earlier in the class to deal with all these other parts of the class for your assignment, and that's perfectly fine. Last year, a lot of students made their projects just using straight up CGI. It's completely fine for the class. But so let's just try to think about what are some of the limitations of this model. So ideas. Yep.
I'm not sure, but do you have to use Apache for CGI?
So do I have to use Apache? No, you can use other pieces of server software as well. But Apache is what comes for free, right? That installing that AMPS thing just installs Apache with CGI. Apache is the most common one, but other web server software, like I'm sure Node even supports it, but Nginx or other ones support it. But most commonly people use Apache. Yep.
Is one of the limitations that you have to refresh the page to see updates?
Okay, so refreshing a page to see updates. So that's a limitation of just all the stuff, right? Because the model of that's a good point. So this model of a client-server interaction is you'll have to do this no matter what. So no matter what you do on the server, you have to refresh, unless you use the WebSockets, right? Or Ajax. So yeah, so that's common, unfortunately, to everything. So it's not a CGI specific thing. Other ideas? So what about performance is one thing. We don't study performance in the class, but what ideas about performance could there be? So one thing with CGI is that what happens is, remember how Apache has the server here, and then whenever you make a request, it actually runs Python, right, or runs Ruby or whatever. So it runs Python. What is this? Lecture3.py. So what happens if 10 people are making a request around the same time? Yeah.
You have 10 instances of that script running.
That's right. You have 10 instances of Python running. So because it doesn't know anything better, it will run Python 10 times. So if you're at Facebook scale and you have a million people hitting your site at once, you're running a million Pythons at once. So that's clearly hard to scale, right? So if you take an operating systems class, every program that starts up, every process that launches uses some overhead. It uses some virtual memory. It uses some file descriptors. It uses a bunch of stuff. So the original CGI model is every time someone makes a request, you're going to launch a new program. And of course, these programs don't run for a long time. It runs for a second, it dies down. So it's fine if you have a low traffic site. If you only have a few people visiting, 1 or 2 people visiting a second is fine. But if you have a million people visiting a second, you probably can't use CGI, right? So that's the main performance thing. That although we don't really emphasize performance in this class, that's why if your project's using CGI, it's completely okay. If it's simple enough and use it, we don't need to have 10,000 people on it. So performance. So ideally what you want is you want to not launch separate programs for everybody who visits your site, right? Ideally what you want is if 10,000 people, if this is 10,000x or whatever, 1,000, you want to keep it all within one program because when one program runs, it doesn't have to launch a bunch of different programs on your computer. You just have one program handle everything. So other issues with CGI are the URLs are kind of weird, right? So the issue with another issue with CGI, as you were kind of seeing on the REST thing, is that your URLs are kind of rigid, right? So we have, let's say, Facebook.com, whatever one we made up last time. Create user.py. So in the CGI model, every script you have to really address using the script name, right? So for lecture 3, whatever, you're calling the URL with lecture3.py or lecture4.py, and all your URLs kind of look a little ugly, right? Because they all look like the name of the script. So what you'd want for the rest I'll go over the rest thing in a bit, is you want the URLs to kind of look semantically meaningful. Ideally you want your URLs to look like facebook.com, /users/John, or something like that. So in this model, you can't really do this in a straightforward way with CGI because there's not really naming a particular script. So it's the URLs are another thing that sort of get in the way. So that's another reason why you might not want to use CGI if you want to have URLs that kind of look nicer. A third reason that's sort of related is that just historically, if you're using CGI, you're relying on the language itself and their libraries that it has to do things like setting cookies or parsing forms or doing stuff. And some languages like Python have the import cookie and stuff, but usually most languages aren't made with a lot of functionality for handling web applications. So there's no reason why you can't import new libraries or do stuff, but it'll be nicer if there's just a nice package to put everything together. So the basic idea is performance is one thing. You don't want to launch a bunch of programs. You want your URLs to be kind of clean looking. And finally, you want to have a lot of libraries and other code, support code for helping your web app. So people throughout the years have kind of reinvented the wheel several times and tried to build more and more of this functionality into their web servers. And basically, it ended up looking like what we now call web application framework. So who has heard of the term web framework, web application framework? Good. So yeah, if you're kind of looking for jobs or internships or kind of doing hobby projects and such on the web, you often hear about this term framework or what framework or stack you're choosing. And so really I want to just go over at its core what it is. So at its core, I have some readings, which I didn't put up in time this time. You can read it for next time. This is a pretty good intro reading of what is a web framework. And Wikipedia is also decent as well. But basically, these definitions are decent, but they're kind of unhelpful, right? So it's like, what's a web framework? It's a framework that helps you build websites, right? That's basically the definition. The extent, if you Google around, all they say about web frameworks is it's a framework that helps you build web applications, which doesn't help anybody. But basically what you can think of is just a collection of code, like libraries and stuff, that just makes your job easier so you don't have to reinvent the wheel. Like many things, if you're, say, programming a 3D game, you're using some 3D game programming framework that has a bunch of libraries and features and development environments that help you build games instead of writing from scratch. So if you're building web application, these frameworks are just conveniently packaged tools that help you do common things. So common things that you might want to do with web frameworks are, let's see, features. So here are some common things. So a framework doesn't need to have all of these, but usually they have some of these. So examples are, the thing I just mentioned earlier is URL mapping, which is really transforming those nice URLs into like actual scripts you want to run. So your URLs can be really clean. There's security issues. There's web templating, which means, remember with CGI, all we're doing is just printing a bunch of HTML. And that can get kind of messy. So there are these templating systems that lets you construct HTML with little variables inside. So you can kind of put custom content in your HTML. There's database access. So there's code to help you access the database. Because remember, a lot of your web apps will use a database. So there's support code that helps you, get data from the database, put data in the database, just make it nicer. Ajax. So there's kind of code that helps handle Ajax requests and such. So these things are really what you'd want in a modern web app, right? If you think about what you want in a web app, and what a framework does is just provide code to help you do this, right? So there's no reason why you need to use a framework, but if you're familiar with one already or you want to use one, it just they were designed by people who have built web apps before, built these modern web applications before, so they want to give you a lot of this functionality essentially for free. So of course, the issue with web frameworks is several-fold, right? So the first issue, so let's see. So we are in web frameworks. Okay, so the first issue is, I alluded to this earlier in different lectures, is how should you choose a web application framework? So I guess I'll ask you also, how would you choose a web application framework? Which one is the best one?
The popularity will tell you something about it.
Good, so popularity is good. So if a lot of people are using it now, then that means there's probably good documentation, and you might be able to get a job doing it, which is a good thing. Yep. So if you choose a framework that's 15 years old and nobody's committing to it anymore, you probably won't get good help. So that's good. Other ideas? Yep.
If I know Python, then I will choose Django.
Good. So if you know Python, you would choose a framework written in Python, so you don't have to learn a new language. Yep.
So just checking and seeing what attributes it does have.
Good.
Making sure it has Ajax support.
Yep.
Or use Ajax.
Yep. So checking the features, right? So there's there's this, right? So some frameworks might have everything, some frameworks might have very little. And it might be, maybe you just want a minimalist one, because if a framework only has a little bit and that's exactly what you need, maybe that's actually good because you don't have to learn all the other overhead with it. But if you need everything, then you probably want a really big, full-featured one. Cool. Other ideas? If you've had to use web frameworks before, how did you choose? So basically covered most of it. So, popularity, which is good. Features, what features you need, and then language is another one, right? So if you are an expert at doing Ruby, you probably want a framework in Ruby because then you could, code really fast in it. Yeah, so it turns out those are all really good ideas. There's no one size fits all. And popularity is interesting because what's popular today might not be popular in a year or two, so you have to kind of adapt to that. Language, again, you might need to learn a new language if that becomes more popular. So Wikipedia has this comparison web application framework that I showed before, that there's all these languages, all these features, and basically, where is it? So these are different languages that have web frameworks in them. So these are languages. So there's a ton of these, and this is not even a complete list. So a bunch of Java ones, a bunch of JavaScript ones. So Node.js is what we're going to look at in more detail. Scala, Perl, PHP has a bunch. Python has a bunch. Ruby has a few. So Ruby on Rails is a really popular Ruby one for those who've used it, and then other languages. So here's the feature table right here, right? So there's things like Ajax support, this model view controller, this object relational map. You don't need to know any of these details, but testing, security, template, caching, whatever. So basically, it gets kind of overwhelming. There's like a bazillion of them, and they each have different features and different sets of things that they're good at and not good at and such. And so the purpose is these two lectures, we'll just pick one. And like Jamie said, we're going to pick it's good to pick a popular one now because otherwise there's not much of a point. So I just Googled for Web Framework 2015. So this page is a definitive list of what you should learn. Or no, I mean, everybody has their own opinions, but according to this page, which is very JavaScript centric, what should you learn in 2015? So Node.js, I don't know where they got this pie chart. So Node.js or the JavaScript framework is, I guess, the most popular based on some metric of people who like Node.js, and these are some other languages and frameworks people use. This is a weird graph because I don't know what they're comparing. These are different ones, again, just more and more things. JavaScript is everywhere, blah, blah. Angular is one in JavaScript that you could use. There's all these terms. So we're going to use Node.js using this Express package. Databases, blah, 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 blah. There's all sorts of stuff here that could be really, so there's Django, Ruby on Rails, and all this stuff. So again, the purpose is, whatever you feel comfortable with, should be something somewhat modern so that people have documentation on it, people are talking about it. But really, anything that seems actively developed and you feel comfortable in the language and you can set it up, feel free to use it. One of the harder parts about frameworks is actually setting it up and deploying it on your server. So CGI is really easy to deploy because any cheap $5 a month web hosting service has it. But if you want to deploy these things online for a real application with the framework, one of the issues you'll face is it may take forever to set up. So that's why for this class, at least for this project, you do not need to deploy online. So all the grading will be done in person when you're demoing to your TA. So that makes it much easier. Yes?
I'm still kind of confused how web frameworks, how they differ from like libraries for languages themselves.
Yeah.
Like how you have JavaScript and then you have JQuery, which is a library, but then you have things like Node.js.
Yeah.
Or Abstract.js, and those are frameworks.
Yeah. So the questions about frameworks, libraries, and stuff. Yeah, that's why, these are ill-defined terms. I would say, those are all basically different words for the same thing. So in your particular question, so remember JavaScript runs on the browser? So jQuery is a library for JavaScript in the browser, right? So this is a JavaScript library. There are also, there are also frameworks for the browser, like there's this thing called Angular, which is kind of in the browser. There's this thing called React. There's some other ones that are just pieces of code that help you do JavaScript in the browser. And those, you could call them frameworks or libraries or so forth. Usually people use the term framework to mean something a little bigger than a library. I think that's the way to think about it. That a library could just be one file. A framework is like this big, massive thing. Yep, question there. I'll get back to yours in a second. Do you have an idea?
Something like Dreamweaver considered to be a framework?
It's a good question. So Dreamweaver, I would say, so Dreamweaver is kind of an IDE or development environment for things. I would say that's more like a tool, like a text editor. So I would, maybe Dreamweaver actually has some support for building web apps as well. So it's sort of blurring the lines, but I would view Dreamweaver or something as like a tool you use to build stuff and not as a piece of code. So we're not, so it's just like using Sublime Text or Eclipse or something. But back to your point about the framework. So there's JavaScript on the browser, which I think this is why it's confusing. So then there's JavaScript on the server too. So Node.js, Express, and these other ones, these are things or frameworks or libraries or whatever you call them for JavaScript on the server. So that's the main difference in what you just asked. That these things are JavaScript in the browser and these things are JavaScript in the server, even though they're both JavaScript. So yeah, I think the best answer to that is frameworks are kind of bigger things than libraries, but they're essentially the same idea. They're just code to help you do stuff, so you don't have to do it again. And people sometimes use them interchangeably. But this actually brings me to segues a good point, is that we are always used to using JavaScript in the browser, right? But now what we're going to do is we're going to use JavaScript on the server as well, because there's no reason why you can't run JavaScript in the server because it's just a language. So for the remaining part of the class, we're going to study this framework called Node.js and Express, which all takes place on the server, right? So the jQuery stuff is all in the browser, and Node and Express is on the server. Does that make sense? So this is actually the tools we're going to use for the rest of this lecture and the next lecture. So jQuery, which you've already seen, is JavaScript in the browser, and Node and Express is JavaScript purely on the server. Okay, so where are we? Okay, so one example framework here. So this is what we're going to do for the rest of this class here. So how many of you have worked with Node.js or kind of seen it in action? Well, beyond just last week's class. So some. When did you work with it? Okay, so you made a Chrome app with it, and that was the server. The server was in Node.js. Interesting. Did you work with it as well? Okay, cool. Yeah, so it's a piece of server software you can run. So I guess I'll try to draw the high-level picture of what Node.js is. So remember, in the old world, with the CGI world, the piece of web server software is called Apache, and then Apache has some CGI thingy on it, and then that launches a bunch of CGI programs, a bunch of Python programs. So instead of using Apache as our web server software, which uses CGI, we're going to replace Apache now here with what's called Node.js. So Node.js is, for the purposes of this class, Node.js is a piece of server software just like Apache, in a way. So instead of using Apache, we're not going to use Apache anymore for these 2 lectures. We're going to take it out totally, and we're going to use Node.js instead. And Node.js just happens to be written in JavaScript. And it enables you to write software on the server all in JavaScript, in JS or JavaScript. So Node.js is like Apache. We'll just cross out Apache, replace Node.js. But Node.js by itself doesn't really do that much. It just kind of handles your requests and responses and stuff like a basic server. To do anything really useful, you have to install this package called Express. So instead of, I guess, CGI here, the equivalent picture here, in a way, is you have to install this thing called Express, which sits on top of Node.js. So this is a even more confusing. This is a library or a plugin for Node.js, which is itself a framework. So again, Node.js, yes?
Oh, if Node.js is better than Apache, why people will use Apache?
Why people are using Apache? Good question. One, it's much older, right? So a lot of servers have used Apache for many years, so they're not going to switch over because they have a billion people using their website. You don't want to just pull the plug and switch something else. A second one is it's unclear whether it's better, right? That people could argue whether it's better or not. People argue both sides of whether it's better. It's just, I would say it's different, right? I don't want to say it's better. It's just another thing that you can use instead of Apache. But people use different servers that are not Node.js, they're not Apache. There's maybe 10 different server software people use. Yep.
So what exactly is Node.js again? 'Cause
Yeah.
Last time you said something, it's like basically Google Chrome's V8 engine is like ripped out and turned into like a standalone software.
That's right.
So from that, like, it sounds like it's just like a JavaScript compiler. Or is
Yes.
it more than that?
Yeah, so this is another confusing thing as we get into Node.js. So at its core, actually, what just happened? So at its core, if you install Node and just run Node, it's actually just a JavaScript interpreter on your computer. Is this? Right, it's not interactive. Did I have? Okay, so let me make a hello.js here. So console.log, hello world. This is JavaScript code, so console.log. Console.log means print, right? 1 plus 2, which should be 3. So if I save this and I run it with Node, hello.js, I'm just running a program. It will just run on my computer, right? So at its actual very, very core, Node.js is simply JavaScript running on a server, on a computer, right? So it's actually just, the basic layer is just JavaScript running on the computer. But on top of that, I guess Node, in addition, provides a piece of software that is basically like Apache. So not only can you run JavaScript on the server, you can start up a web server and listen for connections and stuff. So those are both kind of together in one thing. But in order to make a server using JavaScript, you need to be able to run JavaScript. So at its very core, Node runs JavaScript. Other questions? Yep.
Yeah, and one of the links that you provided for this lecture,
Yep.
an absolute beginner's guide to Node.js,
Uh-huh.
it says that an important thing to realize is that Node is not a web server.
Yeah, that's a great question. Yeah, so more than $1. So by itself, I would say that Node is not a web server, but Node has the code in it for you to start a web server up. So I think these definitions are kind of vague, but I think for this class, you could think of Node as a web server. That it has enough built-in functionality to start a server. But by itself, if you're just putting hello world, it can just run hello world. Cool. So you need to install this Express module. There's some other modules that you might want to install on top of Node as well. Wow, these pile on top. So another reason why a web application framework is useful is that there's a bunch of libraries that you can install on top of it. So if you're using something like Node.js, there is a package manager called NPM. How many of you have heard of the NPM term? I got beyond just yesterday's class. So NPM is a package manager for Node.js. What this means is that people have made code for doing all sorts of stuff that you might want to do with your web apps, and they put it on this repository called NPM. Blah, 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 blah. There's probably a bazillion. Yeah, look at this. There's like a bazillion packages here. So there's almost 200,000 packages a bunch of downloads. There's a bunch of downloads. So there's a lot of stuff in here. So what npm is that it's a repository of code that you can import and add to Node.js. So that again, this is again, we're talking about the web framework idea, right? You don't have to use a framework or anything, but if you use Node.js, you have access to almost 200,000 packages of code that other people have written to handle all of their common web application type things. So you can just Google around, and if you're trying to solve a particular problem in your web app, chances are if you Google around and you go to Stack Overflow, someone is going to say, oh, I made a package for this in npm. All you have to do is just install it and import it, and you can use it in your Node app. So this is another, I think similar to Jamie's point of popularity, another reason why you want to use a modern web application framework that's the most recent is that and the most popular. The most popular ones are going to have the most popular packages. So not just because the language is good or whatever, it's because if you have 200,000 packages, it's probably a better framework than one that has 3 packages, right? Because there's chances are someone's going to have code that you want. So there are other package managers like Ruby has one, Python has one that have a lot of code in them. But I think Node is probably, let me just look it up. So npm package manager popularity. I think it's like the most popular one now, or yeah, they raised $8 million. Okay, must be popular. Yeah, JavaScript package. It's basically one of the fastest growing ones. And again, this is just because it's 2015, right? If you go out and you work in 2020, it might be very different. So 5 years ago, probably the Ruby on Rails, the Ruby ecosystem, I would be giving the same lecture 5 years ago, and you just replace all of JavaScript and Node with Ruby and Ruby on Rails. And 5 years before that, it might have been Python and Django. So in 2015, Node is the thing, but don't take this as gospel as this is going to be around forever. It's just what is popular right now. But we have to have something to use. Okay, so once we have this, we basically have the makings of a web application that you install Express at least, and you can install a bunch of other stuff for handling whatever stuff you want, cookies or logins or sessions or whatever else you want in your application. There is probably a package for it. So if you want to use Node, definitely Google around for packages, and your application will basically look like, let's just scratch out Apache. It'll have Node.js in the base, and then you install a bunch of these packages. And then in addition to these packages, you write your own code, right? You write your own special code, and all of this together will run on the server. And most importantly, it'll run on the server as one program. So this will run as one single program on the server. So now if you get 10,000 requests coming in, there is one big program that handles all of those requests at the same time. You don't have to launch 10,000 programs. So Node, one of the reasons why people like Node is that it's actually pretty efficient, that it handles everything in one giant program that's actually fairly fast. So that's basically, this is in the abstract, this is how you build a web app if you want to use Node. You install Node, you install at least Express, then you pile on and install as much other stuff as you want. Then, of course, you have to write your own code, right? You have to write your own code in JavaScript, which is how do you handle different requests and what pictures you print out and what stuff you do. This is the logic for your own project, and you link it together with these packages, and then you link it together with Node.js, and you just put one giant thing on your server, and then that's your app. And then you deploy it somewhere, and a bazillion people use it. So questions about the super high-level general format? Yeah.
So when someone makes a request to your server using Node, does that program run on the server each time someone makes a request, or does it run like once and then the same output is given to everybody?
That's a great question. So what happens when we'll actually do this in the code is, when you're ready to run this program, you just run Node. Let's call your program server.js. I'm just going to name it server.js. It's just a JavaScript file, right? Your thing's a big JavaScript file called server.js. What you do on the command line is you run node server.js, server.js, and that program just runs, and it just stays running. It's just on. You have to do some tricks on the server to prevent it from dying, but it just stays on, and whenever someone makes a request, the server will handle the request, return the results, and it'll just keep running. It keeps running. It doesn't, as your second part, it doesn't return the same thing for everyone, right? If 10,000 people are requesting different things on your application, they're going to get 10 different responses. But there's only one program running at all times. So if that program crashes, you're kind of out of luck. Well, you usually just restart it, but that's usually how people deal with it. But yeah, there's one thing just continually running. It's quite different from the CGI model. Other questions before we go into the code? Okay, so this was that super high level overview, but we'll actually spend the rest of the time in the nitty gritty of the code. So the code is pretty long for this lecture and the next one. So I actually have it all on GitHub written. So we're just going to go over it because it'll take forever to actually write. So the other thing about frameworks is that it's very hard to write a hello world because you have to set up all this stuff. So whereas with CGI, I could just say print hello world, right? Just print the HTML hello world. But with these frameworks, the bigger they are, the more you have to set up. So we're just going to actually go over pre-written code that I wrote yesterday. So basically, this is what we're going to use during the rest of this lecture and spanning in the next lecture. So we're going to build a super simple Facebook. We're going to use a modern framework like Node.js and Express. We're going to, on the front end, we're going to use jQuery and Ajax, just like we did in the previous parts, right? We're going to have some JavaScript. We're going to have some Ajax calling the server. In the server, what we're going to do is we're going to implement this REST API. So again, this is going to be a recap of lecture 9 again, which will be important for your exam, of this REST idea. So the server, the backend will be in this REST fashion. So in this whole thing, we'll get to see not only the Node.js and Express, we'll also see this REST in action. So you see what actually it means. So if you want to follow on the code, it's actually quite easy now because the code is all on GitHub and all ready. So if you want to follow along, the code is in the CSC210 directory. If you go to just navigate to CSC210 2015 like that, should be a link from the homepage as well. So if you click on www and then lectures 11-12. So I'll introduce you to the format. So there's one file in here. It's called server.js, unsurprisingly. So this is the server file that you're going to run with Node. And then there's a static underscore file subdirectory. I didn't have to make a subdirectory, but I just wanted to separate all the files separately so we didn't confuse things. So there's one server.js file that runs on the server. And inside static files, I have a bunch of files. So I have all the familiar bear, cat, dog pictures. So these are pictures that we've all known and loved, right? All three pictures. I have the fake book that I call that HTML. So this is the HTML file that's the front end, right? The HTML file is the front end of our app. And then I downloaded jQuery. You don't have to download jQuery, but I wanted to make this example self-contained so you don't need the internet. So I downloaded jQuery, but you can just use jQuery from the website as well. So this is the front end of the web app in static files. And the back end or the server is in just server.js here. Okay, so let's actually get cracking on the code. So we're just going to do this technique of just commenting out code first. So first what I want to do is just check it out from GitHub. So I'm just going to start from scratch. So this is, move it down. This is a git clone, right? So git clone, blah, 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 blah. This is just checking out the Git repository from scratch. So take a little bit of time, go. And then now I have a directory, and then cd csc, ls, cd www, cd lectures 1112, and then ls. So notice how I have my same files, right? I have the server.js, and then I have a bunch of static files. If I cd into static files, this is the fake book HTML, the dog, the cat, pictures, and so forth. So there are only a few files here. Now we're going to actually edit the server.js. So actually, it's getting back to your question up here about what is Node.js. So I am going to just open up the server.js file. I got to find it first. Blah, 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 lectures 1112, server.js. OK, so this looks really giant. I'm just going to start commenting stuff out that we don't need. Wow, there's a lot of stuff. Let me put your static files in here. Blah, 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 blah. Let's do some as a database, blah, blah, blah. OK, so you can look on in your copy, or we can look at this copy. So first, there's a ton of comments for what you need to install. So the first thing a lot of apps come with, a lot of code comes with in a framework is you have to install the libraries or the modules. So there's more advanced ways to do this, but I just put it in the comments. So basically, you have to run from your command line npm space install space express. That's the express module. And then there's also this body dash parser. This body parser module is what parses the post request bodies. Again, I found this out because I tried to parse the post request. I couldn't. And then I looked up what's the best way to parse the post request. And this is, I guess, the most popular module for doing this. And I'll grab it. So What I'll do is on the command line, I'll run this. This is all part of the setup stage. Where is it? So I'm in here, and then I just run npm install Express. It takes a while to run. It actually will download Express from the npm server and then install it in my directory under node modules. And if I do the same thing for body-parser, I think that's the other one I need. So Express and body-parser. So on your app, if you need a bunch of stuff, you just keep on doing npm install for whatever you need. It all goes by default inside of your folder, which is nice because it's all self-contained. So now what I should be able to do is actually run it. So the instructions here, if you want to set up later run yourself, is now what you should be able to do is just run node space server.js. And that will actually start your web server up on localhost on your computer. So how this works is there's a bunch of code that sets up that you have to see here. So this require is sort of like if you're using Python, it's like an import. So it's an import in Python. So I am actually importing or requiring the Express module, and I store it in this Express variable. And then I make an app by calling Express, I guess how you do it. Body parser, again, is I require this body parser module. So in order to use Express and body parser, I need to have them installed first, what I just did. And then I set these things that I found on the internet, on their tutorials of, this is how you set up the basic web app, which is you create an app, which is using Express. So this variable represents the state of your app. And then there's this app.use, which uses this body parser thing. So again, you're not expected to be able to write this code from scratch. How you would realistically do it is you would look on the internet and see how people set up the apps, right? So this is one of the things we're starting already getting to web frameworks, is that you're not going to be able to understand all the code. You're just going to be like, this is how you use it, just copy it and pray it works. And the heavier the framework, the more praying you have to do. So the simpler, this kind of get back to your features question, right? The simpler the framework, the less praying you have to do because you understand the code. And the heavier the framework, the more praying you have to do. Yep.
So for citing sources when we're doing our projects, should we just have like a document of all the places we got code from, or what would you like us to do?
I think for these, I think it's fine. It's self-documenting. So like Express body parser, it's fine. Just if your thing actually runs, you have to have imported it correctly. So those are fine, but I would say for citing, if you're like copying like a function that does something really custom, then you should cite it. Like I got it from Stack Overflow, but these standard imports, don't worry about it because it's implied that they come from NPM and everyone uses them. That's a good question. Yeah, that would be torturous to have you not use these because then it's impossible to build anything. Okay, so then the last thing with our app is I'm going to scroll all the way to the very bottom. Actually, let me comment this out. I'm going to scroll all the way to the bottom. There's a lot of stuff here. Ignore. The last part of our app is this thing right here. Is var server equals app.listen. So this line at the very end will actually start your web server. So this app, remember app is our web application. .listen means start listening for requests on port 3000. I just picked a random number. 3000 is the one I like. And then this says when you start listening, print out this message to the screen. So what this does is that this actually starts your web server. So let me actually comment this out so I don't actually start the server, and we'll see what happens. It might break, but let's see what happens. So if I don't start the web server, let's instead just say hello world, just for fun. Okay, so there's a script that does a bunch of setup and then just prints hello world. If I run it, I'm just running it, right? Just server.js, I'm just running it. If I run it, what do you expect to happen if it doesn't break? It prints hello world, and then what happens? Does it start a server? No server. Yeah, it just says hello world, and it just quits, all right? Because that's not super useful because my program just quit. So really what you need to do is you need to have some line to start the server. So this line starts the server here. It's not, well, let's do hello world before. Actually, well, let's do hello world before, just to be nice. So we'll do hello world, and then we'll start the server. So now, if this works properly, what should it do? I just said it. What should it do? Yeah, it says hello world, and it starts the server. Now, does the program exit right after this? No, it can't exit, right? Because says hello world. Now it prints out server started at localhost, whatever. Now notice the program is hanging. It's not exited. Because if the program exited, then we can't have a server because the program just died. So this is what I was talking about in the in this slide, right, messy slide right here, is that you run it once, you run server.js once, you run it once, and it just starts one program on the server, and it just hangs. It just hangs there, and it stays open. And it doesn't exit, because once it exits, it's gone. I mean, you can I can close the browser and exit it, and it'll be gone. So now what is it doing? This is kind of weird, right? Because usually when you're writing a program and it's hanging like this, it's probably because it's infinite looping, right? Like you're calculating something in infinite loops, and it's just like driving your computer crazy, and you kill it. But in fact, this is not infinite looping. So what is actually going on here? It's hanging, though. Yeah.
Waiting for requests.
Good. It's waiting for a request. So it's actually basically. In your OS, it actually opened a socket in your operating system, and it's just waiting there until someone makes a request. And because we set up the server so that we're on port 3000, anytime someone makes a request to localhost 3000, it will actually run some code on the server. So let's try to do that. All right, we ran our server. So this was not very useful, but something ran, which is good. So whenever we make a request now to the server, let's say, what do I want? I want the cat picture, right? Cat JPG. So what's going on here? Something's happening, but it's not what I want, right? I want to be able to get all these pictures out. So what's wrong now? So I started my server. It's all good, right? And I have all these files. So maybe I should do like static files or something. I can remember the dogs are in static files like that, right? So maybe that works, but it still doesn't work. So the problem here is that I started the server, but I don't have any code to tell the server what to do when the user makes a specific request, right? I didn't write any code to tell the server what to do. So it is like James quoted, we just started a web server, but it's very dumb, right? It doesn't do anything. So what you want to do, the first thing you want to do when you start your server to make it act a bit more like Apache, let's destroy the hello world here, is to go all the way back to the top, and I commented out one important line here, which is app.use express static files. Okay, so what this line does is that it tells the app to treat all the files in the static underscore files directory as just static, just normal files to serve up on the web server. So if I do that, that means that whatever I put in static files, I can actually request, and the server will actually return them to me intact. So this is like just loading straight up HTML files, JPEGs, pictures, and anything. There's no actual script running. We need to do this because otherwise we can't get the actual files out. So remember the static underscore files directory and this line. So if we uncomment this line, first of all, to get this to take any effect, what I want to do is I want to restart the server, because you can't really just update the code, right? Because if you update the code, the server's still running. So I do Control-C, and that quits the server. So notice if I Control-C and I try to go get dog or whatever again, it just hangs because there's no server available. Right, so this says not available because there's just, I'm not running a server anymore, right? There's no server running. The thing is exited. So what I want to do is just run node server.js again. I'm going to restart it. And now what happened is this line, this static line is in. This means that every file in static files in here, where is it? Where's on my computer? Every file in static files, lecture stuff, lectures. I'm just getting back to the 12. So notice how I have the static files directory here. This is, I told my web application, go look in here and serve up all of these files just as themselves. So what is in here? If I cd into static files, remember I have the dog, bear, cat, fake book, whatever, right? So now what I can do is I can, in my web browser, if I simply request, oh, I actually have it. If I request dog.jpg and press enter, it will actually know to go in static files and find it's a giant tongue, and find a dog.jpg picture. And if I say cat.jpg, it'll find the cat.jpg picture, and what's it, bear is the last one. So notice the key thing here is I did not say this, right? Because you intuitively expect like that. Right? So this is a common mistake, because you're like, wait, this is in static files, so shouldn't I say static files / bear JPG, right? Yep.
I don't know if I just press enter again, but did that re-update the
That's a good question. Yeah, that was kind of magical. I think maybe because the browser kept trying to reload, but that does not happen automatically. Yeah, I think the browser was trying to reload maybe automatically, but yeah, it doesn't normally happen. So you think that you want to put static files there, but in fact you don't need to. Actually, you shouldn't, because the way the framework works is they want the URLs to be as clean as possible. So they basically say that any URL you request will go to a URL. Will go to, well, that's a giant picture. Will go into static files to find the bear in the picture. So now begs the question, let's just start this fakebook.html file, right? Now we can actually load the fakebook.html file because it's a straight up HTML file. There's no craziness going on. There's no scripts or anything going on. So then what I do is I go to here and I load .html. Okay, so this is we'll go over the code in a bit, but this is the app, right? So there's a straight up HTML file. There's nothing funny going on. If you look at static files, fakebook.html, it's just it's kind of long, but it's just a bunch of HTML with some JavaScript inside. So it's just HTML with some boxes and such. And we've just loaded it here. So recall you have to reload, and this is the app right here. So questions so far about how this happens? Yeah.
Is it required to put all the founding files into one folder?
Sorry, is it?
You have to put all the files into one folder?
Did I put all the files in one folder? Probably not. So let's actually do an experiment. Let's actually make a subdirectory, right? So under static file, let's make animal pictures, and then let's copy cat.jpg into animal pictures, and let's see if we can actually get animal pictures, right? So let's see if we can do pictures / Yep. So this will work. So now anything under static file, you can actually put in subdirectories, and these actually go in the subdirectories. So that actually works. So the best answer to these is try it and see it happens, and it turned out it works. Okay, so now we basically, with this, let me go back. With this basic framework, we have set up a web server just like Apache, very similar to Apache, right? Using this few lines of code, by setting the static files and doing some importing and whatever, and on the very bottom, doing the server listen thing. This thing looks kind of like the Apache server, right? Because you visit localhost, you request HTML file, JPGs, whatever. This is lecture 1 or 2 or 3 or whatever. And so this is like a duplicate of doing Apache. Okay? Yep.
Do we have to install Express and the body parser every time we try to run this? Because last time I think I installed Express, but this time when I tried to run this one.
Yeah, that's a great question. You the way how to think of installing stuff is that when you just do depends on how you configure, but when you do npm install, let's try it again. It should say it's already installed. Go. Yeah. So when you install something, it actually goes into the node module subdirectory in your directory. So when you tried it last time, you were in another directory. And when we tried it this time, it was in this directory. So the advantage of this is that you can just zip up this whole thing and just give it to somebody else, and they have all the files. Disadvantage is you have to do it again. There's an option called, I think it's like -G, that'll actually install it in some global cache somewhere, so you don't have to redo it, but then you have to have root access and stuff. So the simple example is install everything in the directory. But yeah, it's kind of a small issue. That's a good question though. Okay, so now we have our app. So, because we don't have enough time to go over all the code today, I'm just gonna show you what the app does first. So what this app does is this is a CRUD app, just like what you do with Ajax. So what you can do is I have a few people in my database, so Philip. So this is CRUD right here, right? C-U-R-U-N-D. So I'm just gonna read a user's profile. So what this does is that it takes the name you put in here, it looks up their profile in the database on the server, and then it returns you their data that you can display. So I do that, it says name, job, and then I have a profile picture right here. If I put in, I think John, is another one, read, John student, whatever. So this is actually going to the server, looking in the database, grabbing the data back, and putting in here. And then I think I have Jane with the third person. And then if I request an invalid one, like, I don't know, Carol or something, it should give an error. Yeah, it says error could not find user, right? Because I'm not in the database. So this is like a reading. So what if I want to create a new user? So if I want to create Carol, I'm going to put in job, scientist, pet, I'll say cat again, cat.jpg. When I click create new user, it says, oh, successfully create a new user. Great. So it actually does something on the server, creates a new user, puts in the database, and says success. If I try it again, it'll say error because Carol is already in the database. So that's what you expect. Now what I can do is I don't have to fill in these. I have Carol in here. I read user profile. This should read Carol from the database, right? My name is Carol, scientist, whatever. If I want to update, so let's say I want to update Carol's job to, I don't know, skydiver or something. I put in her name and the job. I click update, and it says successfully updated. So now if I look up Carol again, I read, it'll say skydiver. Oh, I actually didn't put in the pet. There, it's bugging my code. I should. This actually overrides both the pet and the thing, so the pet's empty. But let's look at Philip again. Read, great. So let's say I want to delete myself from the database. So I delete. It says successfully deleted. If I try again, it'll say cannot delete because I'm already deleted. So now if I try to read myself, it says I'm not in there anymore. Right, because I deleted it. So this is exactly the behavior you would expect for an app that's like this, right? You're creating new users, reading profiles, updating users, and finally deleting the user. Okay, so this is completely, the front end is completely implemented using, the front end is all HTML. I don't actually have any CSS, I don't think, because it looks ugly. There's JavaScript. And then plus jQuery is the library I'm using in the front end, just like all the stuff we've done so far. That's all the front end is, HTML, JavaScript, jQuery. You can obviously have CSS to make it look nicer. So the front end code is all in the repository here. Remember that it's in static files, so you have to go not only lecture but in static files, because in order for the server to serve up the HTML file, it has to be in static files, and it's just this fake book HTML. So I will start skimming through this code. I won't spend a ton of time looking at it, but you can study it offline. And we'll go over it tomorrow, Tuesday also. Where is lecture 1112? So here is fakebook.html. So it is kind of giant, but it's well documented, hopefully. So there's a title, blah, 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 blah. Let's just go to the bottom. Here's all the HTML. So there is 3 text boxes, name, job, pet. Each box has an ID, name box, job box, pet box, which corresponds to these 3 boxes, right? I'm just going to reload. Name, job, pet, 3 boxes, 4 buttons, create, read, update, delete, not very creatively named. Button, 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 each button, create button, read button, update button, delete button. So all you've seen so far. Yes, question?
If you want to make the boxes underneath each other instead of next to each other, will you have to do a new paragraph?
Yeah, you can do a new paragraph or like a BR or something like, is that BR? Yeah, like a BR for break or /P or a new div. Yeah, that's all just style. Yeah, that's all just styling. Or you can set the CSS. But yeah, the new paragraph works. I just wanted to keep the code as small as possible. And then down here we have a few empty divs. So this is where you would put the name information. This is where you put the age information. These are empty right now because we haven't loaded anybody. This is a profile image, which we set to 300 just to make sure it's not too wide. But we don't have a, notice how we don't have a source here, right? Normally you put like cat.jpg. This image has no source, which is why the image starts out completely blank. Everything is just blank because these are just placeholders. And the bottom, I just have a final status bar so that you can display errors or things. So these down here are our outputs. So when you do stuff for the on the app, we're going to put everything down here. And then these are the buttons. We have button handlers and stuff. So conceptually, what we want to do is when somebody says, let's just do a read. So without even looking at the code, what you want to do on a read request is if someone wants to read a profile, what you do is that they first fill in their name. Actually, they just need to fill in their name, right? Because we're just requesting a name. We don't need the job and the pet. They fill in their name, like Philip or John or whatever. They click the read button. So this needs a click handler. We click the button. It goes and asks the server for the profile data for the person that you want to read data from. Then the server comes back to you. And then you go down here and you use JavaScript and jQuery to fill in the information about their name, their age, and their profile picture. So that's the read request. So we need JavaScript code to do that. So to remind again, the read interaction is the following: is I I fill in my name here or anybody's name. When I click read, there should be a click handler that says when you click this button, grab this text, ask the server for the profile, grab the data, and then display it down here in the divs in the image down here, right? And then the other ones are very similar. So if you want to create a new user, for example, let's create a new user called Alice. Job is, let's say, skydiver again. Pet is bear.jpg. When I hit create, I want to actually send this data to the server to create a new user. Successful. And if I try it again, the server just responds error. So now if I read the profile, I don't actually need the skydiver or the bear because a read only needs a username. It should read that Alice is a skydiver as a bear, right? Yes?
So when you create a new user, where did this new information store?
Yeah, so that's all on the server, right? So we haven't touched that yet. So all of that will go on the server, and it's probably some database, right? So then you can actually keep it. Yep.
And part of the program that accesses the database, is that in the JavaScript?
That's in the server, but it actually happens to be written in JavaScript because our server is JavaScript. Yeah, because Node.js, but that's database is all server. So the front end or the browser code doesn't know about the database at all. Yep.
Sorry, no.
Do you have a question? You're good? Okay. So we're all just talking about the front end code right now. So this is from a few lectures ago that you'll be able to understand this code. Other questions?
You only have one person named Alice in your database?
Yeah, in this version, yeah, sure. Their names have to be unique. Yeah. So yeah. So if I try to create another new user named Alice, it won't let me because my database only has one person named Alice. But yeah, you can imagine you have a user ID or something more unique. So all of this code looks kind of hairy. I won't go over it in detail, but let's just do the read one. Okay. So this is the read. It's like, what's going on here? So this is the read button's click handler. So remember, you want to set a click handler. So when you click the read button, what are we actually doing? So we are doing this. So we're doing an AJAX call. So remember, this is all AJAX. We need to call the server. The URL we want is this. So what is this URL? So if I have, let's say, John in my text box, what is the URL I'm trying to request here for the request? Yep.
The content of the text box.
Which is John.
The ID name box.
Yeah. So it's John. So what's the string of the URL that we're making?
Users/John.
Perfect. Yeah. So it's the URL we want to request here is users/J John, right? And if I have Philip in the text box, my request is users/Philip, right? So whatever I am putting in the text box, that's actually going to be the URL of the AJAX request. So this looks kind of different than what you've done before, because in the request you're just putting some script in, but now I'm actually making a different URL based on what user is in the box. And I don't care at all right now about how the server implements this, but so if you're if you're thinking about getting a job as a web developer, people often say, oh, are you doing front-end development or back-end development, right? So this is all front-end development. So as a front-end web developer, all I care about is that I am making a URL request right here to user/Philip, or if I put John in, I'm making a request to user/John to the server. And I don't care at all how the server handles this. The server, the back-end people, better do it right and give me the right result, because all I care about right now is the front end, right? And the front end says, I want to make a request user/John or user/Philip, and I hope it works. The request type is a get. So this makes sense because we are trying to kind of get data about the profile. The data type is JSON, so we want the server to give us back some blob of JSON data as a standard AJAX request. And what does this function down here do? And when does this run? So this down here, this is the last part of the code. Yep.
When the server gives back the data to the client,
Yep.
it's a success.
Good. So when the server executes, everything's good. It gives back data to the client. This data is going to be some JSON data. And basically what I do is I print out, you've received some data. And then I actually just, what happens in here? So I guess what happens in here? Yep. That's right. So if the data actually has a name field, if the server gives me data with some name in it, that's not null and not empty, we're just going to update the HTML. My name is, my job is, and this is the source of the profile in there. So this actually just updates the HTML. If I can't find the user, I'll actually just set this to I couldn't find the user, right? Like I just can't find anything. So this basically does what happens when the call succeeds. So if I go here and I put, let me reload, and I put Philip in, I hit read. Whoa, what just happened? Is it died? Let's see. Wait, am I? Oh yeah, I think I deleted myself. Okay, all right, let's not. Who did I not delete? Okay, I didn't delete John. Okay, good. So when I read user's profile, it fills up this. So if I put in myself or I put in some garbage, it doesn't. The data doesn't have a name, so it's just blank, and it says error could not find user. So it sets the status on this. So all of this code should be understandable right now without any knowledge of Node.js or anything. So the question for all y'all is, given this code, what is the backend or the server written in? What does the backend need to be written in, given this code? A good exam question. Well, I guess not anymore, so I asked it. Or maybe still. So the answer is it doesn't, you don't know, right? You don't know and you don't care. It's just, this backend can be written in Java, Ruby, Python, Node.js, whatever. All I care about as a front-end developer is that I can make a request to this URL and get back some data that I want. I don't care what the backend is. We have a really similar flow for the other ones. So here is create. So when I hit the create button, what URL am I visiting? User slash, right? So URL I'm visiting is user slash. And then if this is a post, because I want to post some data, and here is the data I'm sending in the post. So the data I'm sending to the server in a post request contains name, job, and pet, and these grab the corresponding values out of those boxes. And once you've succeeded, you get some data back from the server. It says either it's okay, which means, oh, we've created a new user, or there's an error that says error, I couldn't create the new user. So when I try to create a new user, either I create it successfully, or if it doesn't let me for some reason, like you mentioned, like there's already a person named Alice, it'll just give me an error and I'll say I can't create it. So that's the post. So the style of the URL here is user slash. That's the only URL I'm going to visit. And then what differs now is the data that I'm posting, right? So if I want to make a username Carol, I will put Carol in here. And if I make a username Dave, I'll put Dave in here and stuff. So every time I hit the create button, it will do a post to this same URL, but the data that I'm sending my post is different. Does the post make sense? Again, you don't care how the server does this, but yep.
Why are you using text instead of JSON?
Oh yeah, that's a great question. Why is so why is this text instead of JSON? This is actually the data type of the, I covered it up. So this URL returns plain text string JSON. This is the data type of the actual the response the server gives to you. So this means that this data is just plain text, and it's because my server code for the posts and everything, I'm just returning a plain string called OK or not. I'm not wrapping it in JSON. I could have a JSON, but that means my server needs to return JSON. It's just extra overhead. But don't worry about that too much. But yeah, that's good you're aware of that it's text and not JSON. But you're still sending a bunch of JSON to the server. So that's the post. And then I'll go over the two other ones super briefly. So what are we other one? We're doing update. So we need the update button, which all this code looks very, very, very similar. So if I put, if I put name : Jane in the box, when I hit the update button, what's the URL that's going to be visiting? User/Jane, right? So the URL we want to visit is user/Jane. What kind of HTTP request are we going to do this time? We're doing a put. So we're not doing a get, we're doing a put. And then the data we're going to send in our request is, we don't need to send the name because the name is actually in the URL. We're setting a job and a pet, which again we grabbed from those job and pet boxes. And what hopefully this thing should do on the server, what I want to do is to grab the Jane user, update her pet and her job. and then return me either yes, okay, I have updated, or no, I couldn't update the user for some weird reason, like she's on the database. Yes?
So if you don't put a value, then it would update to blank.
Yeah, in this case, that's right. That was why it was a bug. That's right. So if I don't put in both, that's right. One of them will actually be the empty string. That's why we had that bug. Exactly. So you could imagine making your code a bit more robust against that, but I didn't. Good question. Yeah?
Why the data is equal to OK? I think the data is like the plain text.
Yeah, so why is data okay, right? And you thought it was text. So this is the type of data. So the type of data is text, but the data could be any, so text just means any string, so that the server could return any string to you. It just so happened that the server returns okay if everything went okay. And again, this is part of the server. We haven't written this code yet. This is just, my server promised to return me okay if everything went okay, and if it doesn't, it'll return me something else. And I need to just parse the message. So I'm trusting, as a front-end developer this time, I am trusting the back-end developer to do everything right? This code only works if the server-side code is right. And we'll do one final one, which is delete, which now this sounds like a broken record, but the URL, again, is whatever is in the name. So I'm going to visit users/Philip if I want to delete Philip. The type of the request is a delete request. And then again, if it deleted me, it says yes. If it couldn't delete me for some reason, it'll say no and such. So basically what we've implemented here, kind of the kind of upshot from all this before we end the lecture, is that blah, 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 so we have jQuery in the front end. Basically what we've implemented is the REST API from lecture 9. So remember the create, read, update, and delete from lecture 9. And I remember I told you in lecture 9, we haven't really done this in code yet. This is the thing you should definitely study for exam. The REST API for this Facebook thing, blah, 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 is exactly what we're implementing. So to create a new user, we are posting to users, the user's URL. I mean, this is localhost for us. And then we're passing in name, job, pet. To read a user, we're doing a get request of user / the username. So this is why we have to put the username in the URL, because that's what REST wants us to do. To update, we're doing a put of user / username with a new body. I didn't put a pet in here, but yeah, with a new body. And finally, to delete, we are using a delete request of user / the username. So this front-end code that I've written here, or I've been showing you with all these 4 AJAX functions with delete and whatever, this is implementing the front-end part of the REST API. And you can read this lecture note again for why you might want a REST API. Again, it's not mandatory, but REST APIs are what this sort of REST style, you can do non-REST as well, is what is standard now, and it kind of makes the URLs look kind of clean, because as you recall, you can actually read this in English, right? This is post to users collection, a new entry with blah, 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 blah. So, so far we've had, I'll conclude the lecture right now. What we've had is we had the very much the front end of the code that allows you to do all this magical stuff. And then for tomorrow, we're actually going to do the back end part. Not tomorrow, for Tuesday, we'll do the back end part and see how the server actually implements all this in back end. So I'll see you all on Tuesday then.